Okay, we did limits from graphs, from tables. Now we're going to start doing them from algebraic expressions, which is often how you will evaluate them anyways. The most basic way to do it is direct substitution, and that's normally the method you always start with. So you want the limit as x is approaching 2, which most likely will be the value at 2, unless there's something weird going on at the graph. So I'm going to go ahead and plug 2 in for x. 10 plus 7 is 17. So the limit as x approaches 2 of 5x plus 7 is 17, which makes sense because this is a line. So the limit should match where it evaluates to. Okay, so for this next one, it says the limit as x approaches 7 of 25. Well, the y value is going to be 25 because I'm thinking this is the graph y equals 25. So as x approaches 7, the y always stays 25. Okay, let me look at C. Limit is 5x plus 7 over x minus 7. I'm going to go ahead and plug 4 in because direct substitution is always what I start with. That's 27 over negative 3, which would be negative 9. Let me go ahead and try the next one. The limit as x approaches negative 3 of x over 2x plus 6. Negative 3 over 2 times negative 3 plus 6. So that's negative 3 divided negative 6 plus 6 is 0, which is going to be undefined. So we're going to say the limit does not exist. In the future, we will find a better way to describe that, but the fact that it doesn't exist is enough for now. Okay, the last three are the same. It just happens to have some trig functions. Okay, so I'm going to go ahead and plug in pi over 4. So the tangent of pi over 4 is root 2 over 2, root 2 over 2, so the tangent is just 1. Limit as x approaches pi of cosine of x is going to be the cosine of pi. The cosine of pi is negative 1. Okay, and then the last one, see, limit as x approaches pi of cosecant of pi. The cosecant of pi is 1 over sine. What's the sine of pi? The sine of pi is 0. Because I have 1 over 0, for now I'm going to say the limit does not exist. Although, again, in the future, we will find a better way to describe the limit there, even though it is true that it does not exist. Okay, now I'm going to use direct substitution again, but I'm going to use it for piecewise defined functions, which we've seen before. We've graphed them before. So in this case, it says g of x equals, it's negative 2x plus 15 when 0 is less than or equal to x is less than or equal to 3. It's x squared for 3 is less than x is less than or equal to 8, and it is undefined for any values outside that domain. So the first one says the limit as x approaches 1. X approaches 1. X is 1 is between 0 and 3, so I'm going to use this algebraic expression. There's no reason not to just substitute it in because it is continuous at x is 1. So negative 2 plus 15 is 13. Okay, for the next one, it says the limit as x approaches 7. X is 7 is between 3 and 8. So I'm going to use this expression, so x squared, so this is going to be 7 squared, which is 49. Okay, now it's saying the limit as x approaches 5 from the positive side. Where is x is 5? 5 is between 3 and 8. Whether I approach it from the left or the right side, it should be the same for something like x squared with no domain restriction. So I'm going to go ahead and just plug in 5. Which gives me 25. And again, that's because at x equals 5, this x squared is a continuous function, so whether I approach it from the positive or the negative, it would still equal to 25. Okay, now we're going to get to a trickier situation. So this is saying x is approaching 3 from the positive side. Now the reason this is trickier, because 3 is the dividing line between the two functions. So if x is less than or equal to 3, I'm supposed to use this equation. If x is greater than 3, I'm supposed to use this equation. When I approach it from the positive or negative side, it's going to change which function I plug it into. Okay, so in this case, for the first one, it says I'm approaching 3 from the positive side. So I am still at 3, but I'm a teeny bit above 3. when I think about it in my head, I'm coming at it from a teeny bit above 3. So if I were a little bit higher than 3, I would be at x is greater than 3, which means I'm going to use this expression, even though when x equals 3, it's not supposed to use that expression because I'm just approaching it from the positive side. On the positive side, I would be using that expression because at x equals 3, I actually don't care at all what happens for a limit. Okay, now if I approach 3 from the negative side, remember, I don't care what actually happens at 3, but let me imagine if I was coming at it from the 2.99999 side, I would be in this domain, which means I would be using this expression. Negative 6 plus 15 happens to also be 9, even though I was using a different equation. Now, what is the limit as x approaches 3 of g of x? And when I find the limit, remember, I don't really care what happens exactly at 3. I care that on the left and right, they're matching. So in this case, because these match, then the limit as x approaches 3 is 9. Okay, and the reason I couldn't just plug it in is because 3 is the division between two different functions or two different equations. So they might have different values on the left and right, whereas if I was plugging in x equals 5, from the left and right, I'm using the same equation, so it shouldn't develop a different value. Okay, let's do one more piecewise function because there is just a little weirdness at the division between the two functions. So this is 2 to the x for x is less than or equal to 4. This is the square root of x minus 4 for x is greater than 4. So this is going to be continuous for all the values listed here, so this should be fine. This is continuous for everything greater than 4, that's true. But at x equals 4 is the only time the left and right limits might not match. Okay, so for x is 1, 1 is less than or equal to 4, so I'm going to use 2 to the x. So 2 to the 1 equals 2. Okay, for x is 7. 7 is greater than 4, so I'm going to use this algebraic expression. So square root of 3. Okay, now if I do negative 2 from the negative side, where is negative 2? Negative 2 is less than or equal to 4. So whether I'm coming at it from the negative or the positive side, I'm still using the same equation. So I'm going to just plug it in. Nothing weird happens there. What is that? That's 1 over 2 squared, which is 1/4. Okay, now the only time weird things happens are at x equals 4, because that's where we change the two pieces of the graph. Okay, so first let me imagine I'm approaching 4 from the positive side. When I think of positive, I'm thinking if I was at 4.000001, which function would I be on? If I'm just a teeny bit higher than 4, I would be greater than 4, and I would be using this function. So I'm going to plug 4 into that function. 4 minus 4, the square root of 0 is 0. So if I came from the positive side, the y value would look like it was going to 0. Now if I come from the negative side, I'm coming from the graph that includes 3.9999999, which is less than 4, which means I'm using this one. 2 to the 4th is 16. Okay, now what about the limit as x approaches 4? Well, if I approach from the positive, I get 0. If I approach from the negative, I get 16. Because these don't match, the limit as x approaches 4 does not exist. Okay, and I don't know exactly what this graph would look like, but because from the positive side, 1, 2, 3, 4, it would be at 0. Actually, I do know what this graph is going to look like. It would look like this. From the negative side, we would be doing 2 to the x. So it would be at, what would it be at? 16? So it would be pretty high and it would be exponential. So it would be looking something like this. Okay, so I can tell from the graph that the limit would not exist here because from one side it's going very high and the other side it's going very low.